So hello guys. So today I'll do a question in which a velocity and displacement time graph is given, and the question is like that: you have to find a correct acceleration displacement time graph. Okay, so in question velocity and displacement time graph is given, and we have to find a correct option in which options are given as a acceleration displacement time graph. Okay, so we'll start this solution. So velocity and displacement time graph is given. Okay, so if this graph is given, from this graph what we can observe that slope is negative. Okay, and these values are given x naught, y naught. Okay, now think in that way: if it is given velocity time graph or displacement time graph, we all know what slope of these will represent. Okay, so now we have to think that for velocity and displacement, what does slope represent? Slope represent, okay, so that we can find. Okay, so let's try with this equation. This is dv by dx, so slope is nothing but dv by dx. Okay, so I can write slope equal to y2 minus y1 x2 minus x1 dv by dx. This is my slope of given graph, velocity displacement graph. Okay, so I have to find a relation, and as in options we can say acceleration and displacement is given. So now I have to write a equation. Acceleration is dv by dt. Okay, but here graph is given between velocity and displacement, so I can use another formula of acceleration, that is dv v dv by dx. Okay, this is the same formula. So okay, so I can use this formula. So this formula is given, and we know this dv by dx is slope. So slope I'll get equal to dv by dx equal to a by v. So it will represent acceleration by velocity, so dv by dx. Okay, so now can I find, okay, so this slope is a straight line graph. Okay, this is a straight line, so can I find equation of a straight line? Okay, so we'll try to find equation of straight line. So this is general equation of straight line. So where y is v, y axis, on my y axis I have velocity, on x axis I have displacement mx plus c. So what is slope of my velocity displacement time graph? So see here, slope can be written as y2 minus y1 x2 minus x1. So what are the points x2, x1, y1 and y2? So this is 0 comma v naught, and this is x naught comma 0. Okay, so you can take this one as x2 y2 x1 comma y1. Okay, so now you have x2 y2 and x1 y1. Okay, so slope will be y2 is 0 minus v naught, and it is x naught minus 0. Okay, so my slope I am getting is minus v naught by x naught. Okay, that is nothing but dv by dx. Okay, so remember this. So slope we got. Okay, so I can put this slope value here because m represents slope. So v equal to minus v naught x naught plus c. So what c represent here? C is intercept on y axis. Here what is my and this will represent intercept on v axis, because velocity is there on y axis. Okay, so to find c, intercept on v axis, what we'll do, we'll put, okay, sorry, this there is a x, so we'll do x equal to 0. So at x equal to 0, or you can directly see from graph at what point it is, okay, touching y axis. Okay, so you can find that it will be v naught. Okay, so c will be v naught. Okay, so v naught will be my c. Okay, so now we can completely write this equation. V equal to m is minus v naught by x naught into x plus c is v naught. Okay, so this is my equation of that straight line. Okay, Okay, so now we have this v value, and now we want to find a similar kind of relation between a and x. We have to find a relation between a and x, okay. So I'll start with we have written this acceleration equal to v dv by dx, okay. So v dv by dx we already got, and v value now we got, okay. So v dv by dx is nothing but v naught by x naught. So I'll put these value so that I can get a relation between a and x, means acceleration and displacement. So v is minus v naught x naught into x plus v naught, and dv is slope, that is v naught x naught. Okay, so this value we have written, or directly from here you can write a equal to v dv by dx. Okay, so this value we have put. Why we are doing this? To get a relation between a, acceleration, and x. So if we are getting relation between two variable, we can plot it. Okay, so that's why we got this relation. Okay, so now we'll simplify it. So it will be v naught square and plus x naught square into x and minus v naught square upon x naught. Okay, so this is, again you can see, this is the same kind of straight line equation. Okay, so this we can compare with the straight line equation, where on y-axis we are taking acceleration, slope is represented by v naught square, v naught square divided by x naught square, and intercept is also given. So now it is easy to draw acceleration displacement time graph. Okay, so slope is, from this equation what can you get? Slope is v naught square by x naught square, means positive, it is positive slope. So I'll draw a positive slope line. Okay, and this is the equation of straight line. So straight line will be positive with having intercept minus v naught square c, because c is minus v naught square x naught. So it will be somewhat here. So I'll put minus v naught square by x naught, and it is a positive slope, so it will be like this. Okay, so, and you can also find this value where it is touching on x-axis. If you put a equal to 0 in this equation, so what will you get? X a equal to 0 means v naught square upon x naught square, x equal to minus v naught square by x naught. So this will cancel and one x naught got cancelled, so x equal to x naught, so this will be x naught. Okay, so this we got. Okay, so from this graph you can check which option is matching with our answer. So option number A is our correct answer. Okay, I hope you got this correct, and if you can comment down if you want to ask any doubt from this. So okay, so idea was simple. Okay, actually we have find a relation between v and x. Okay, so because of straight lines, and then we have to find a relation between acceleration and displacement, so that we can get a equation of straight line. So by getting equation of straight line, we can directly plot it, and this option is given in, same plot is given in option A, so that will be our answer. Okay, thank you.